Tonight's presentation, Deadly Switches. Our presenter, Mike Bush. Mike is president of Savvy Aviation Incorporated. He's so much, he gives so much to the community, educating us, but he's an author for numerous aviation publications, to say the least, a contributor to EAA's weekly webinar series by doing one webinar per month, every month, first Wednesday of each month. And Mike's been doing that almost as long as we've been doing this, since 2010. So we sure do thank him for sharing his insights and knowledge and experience with us. Mike is a CFI, an AMP with IA, 2008 FAA's Aviation Maintenance Technician of the Year, and a member of EAA. Mike, thank you so much. I'm going to turn control of the presentation over to you.
Good evening. Tim. Good evening, everybody. I am very impressed. I'm seeing us having about 1,200 of my closest friends here in the room. I don't know if that sets a record. It's got to get close. I guess I need to use the word deadly in all my webinar presentations from now on. At any rate, tonight we're going to be talking about the ubiquitous key operated ignition switch, which is installed in pretty much every single engine airplane I've ever flown. There are a lot of them out there. And this webinar was triggered by a very unfortunate accident that occurred about 5 years ago. Actually, summer of 2018. A gentleman by the name of Larry Kramer, a private pilot from Sarasota, Florida, and his wife Fran flew from Sarasota up to Tennessee, a Cleveland regional jet port in Tennessee, in their Cessna 182, to run some errands. I don't know what the errands were, but then in the afternoon they returned to the airport to depart back for home, Florida. Shortly before 5 p.m., Larry was pre-flighting the airplane. Fran had loaded the groceries or whatever it was they got into the baggage compartment and was standing by the right-hand cabin door, had the right-hand cabin door open, and was preparing to climb into the right seat. At which point, Fran heard a noise that sounded like the plane's engine was trying to start. That didn't seem right, so she ran around the right-hand door out to the front of the plane, and she found her husband Larry lying on the ramp in front of the plane with very severe head injuries. He was non-responsive. Subsequently, not to give away the punchline, but they found the ignition key to the airplane in Larry's pocket. So Fran called 911. Help EMTs quickly arrived. They called in a medevac helicopter, and Larry was helicoptered to a nearby hospital. But unfortunately, he succumbed to his head trauma and passed away. So this was a fatal aircraft accident, even though the airplane never left the ground. And that got the the NTSB involved. So NTSB investigators started looking at things and discovered that the right-hand magneto of the engine's Continental 0470, the right mag was hot. The P lead for the right mag was not grounded out by the ignition switch. And so apparently Larry moved the propeller during his pre-flight, and the engine fired and struck him in the head and caused the fatal injury. When they looked in the cockpit, that they found that there was no key in the ignition switch, but the ignition switch was not in the off position, but it was in kind of an intermediate position between off and right. And in that position, the switch did not ground out the right mag. The right mag was hot. Now, this would be pretty easy to miss. Here's a picture. The left-hand picture is the picture of what the accident airplane looked like. And the right-hand picture is what it should have looked like if the switch was in the off position. And if you look carefully, you can see that there's a few degrees difference in the position of the key slot. Here's a close-up of that. But this would not be something that was real obvious, but it was real fatal. The switch in this Skylane was made by a company called Gerdes. It's one of the 3 companies that make these switches. And it was designed, as all of these switches are, to prevent the key from being removed from the lock cylinder in any position except for the off position. But when investigators tested the switch in the Skylane using the key that they found in Larry's pocket, they found that they could remove the key in any switch position, not just the off position. Further research indicated that a combination of wear on the key itself and on the lock cylinder had progressed to the point where the integrity of the key retention feature that is supposed to prevent the key from being removed in any position other than off had been compromised. The NTSB searched its database and found 3 previous cases where the loss of ignition switch to key integrity, that was the terminology they used, led to an unintended engine startup. And in all 3 of these, the key was not in the ignition, and the pilot believed that the switch was in the off position. These other 3 were not fatal accidents, and so they were able to interview the pilot. Obviously, we're not able to interview Larry. But these other 3 resulted in either injury or uncommanded movement of the aircraft where it collided with other aircraft or with ground vehicles. So now, if there were 4 of these accidents, or episodes of uncommanded starting of a aircraft where the key was not in the switch, that the NTSB got involved in, imagine how many there must have been that the NTSB didn't know about, because typically the NTSB only gets involved when there's either death or serious injury or major damage to the aircraft. So I'm guessing there must have been dozens of these that the NTSB didn't get involved with. Now, these switches come in various makes, and there are airworthiness directives affecting them. The switches were made by 3 companies. The one was Bendix, which was acquired by Continental Motors, Teledyne Continental Motors, and Continental Motors, now Continental Aerospace. And that's the one that's pictured in the lower picture. And then the switches were also manufactured by Gerdes, who made the switch in Larry's Skylane, and also a company called ACS. Now, the Gerdes and ACS switches are basically the same. They share the same design. Effectively, Gerdes wound up going out of business, and ACS acquired their assets and put the switches back into production using the same design. The Bendix switches that are now Continental switches use a different design. I mean, they look sort of similar, but you can see in the pictures that the Continental ones or the Bendix ones have a kind of a cast casing, and the ACS ones have a sheet metal case on them, and internally they're somewhat different. But all of these ignition switches, no matter who makes them, are subject to recurring ADs. The Bendix or Continental switches, not all of the switches are subject to recurring AD, but ones with certain part numbers or certain markings are subject to a pretty old AD called AD 760712, which requires a functional check of the switch every 100 hours. This is a kind of an unusual AD in that the functional check that it requires every 100 hours is one that the pilot is permitted to do. It doesn't require an A&P to do it. Almost all ADs require an A&P, but there are a handful where the pilot is allowed to comply with it, and this happens to be one of those. Usually the check that's required is a very simple check, just takes a moment and is normally performed at the end of the normal pre-flight run-up, although you can perform it anytime you want to. And basically all it requires is that with the engine running, you grab the key switch and you turn it as far to the left as you can through the off detent and all the way to the extreme stop on the left-hand side, because the key switch will move a little to the left of the off detent. And the engine should start to quit. If you hold the switch all the way to the left and the engine keeps running, then the switch is bad, and the AD requires that the switch be replaced before further flight. And obviously, the switch replacement has to be done by an A&P mechanic. So okay, so this is for the Bendix or Continental switches. For the Gerdes and ACS switches, they're subject to a different AD, AD 930506. This is an AD that has a recurring requirement only every 2,000 hours. It's kind of a pain to do, but it only has to be done every 2,000 hours. And every 2,000 hours, the switch needs to be removed from the airplane, disassembled, inspected for wear, corrosion, repaired as necessary. We'll talk a little bit about what that means, and lubricated. In addition, the AD requires this kind of a one-time thing that an arc-suppression diode be installed across the starter solenoid if one is not already there. And since this AD has been around since 1993, presumably almost all of the airplanes have these diodes now. But the diode, which was not originally installed by the manufacturers, suppresses arcing across the contacts of the switch and makes the switch contacts last a lot longer. And it's a little cheap 10-cent diode that gets mounted across the primary terminals of the starter solenoid. ACS offers a very inexpensive kit, about 25 bucks. Last time I looked on Aircraft Spruce, it contains all the parts necessary to comply with the AD, including a new switch backing plate, new movable contacts, the special grease that you're supposed to lubricate it with, and one of these arc suppression diodes, just in case you don't have one already. And the whole kit is about 25 bucks. It's although the kit is inexpensive, doing the complying with the AD is a bit of a pain because you have to get the switch out from the airplane, disconnect and tag a whole slew of wires, open the switch up, basically replace most of the wear components and lubricate it, put it all back together, put it back in the airplane. So that's the AD that affects the Gerties and the ACS switches. Now, we've seen quite a bit of confusion by A&P mechanics over these ADs, and it's not unusual, for example, to see mechanics signing off the Bendix functional check every 100 hours on an aircraft that it turns out doesn't have a Bendix switch, but it has an ACS switch. Also, another thing we see is that a lot of mechanics, or at least some mechanics, seem to assume that ACS switches manufactured after the 1993 date of the AD aren't subject to the AD, but they are. The AD doesn't have an exclusion for switches manufactured after 1993. They're all subject to this 2,000 hour, take it all apart, replace a bunch of stuff, lubricate it, put it back together. What is most noteworthy is that neither of these ADs do anything with regard to the lock cylinder. None of them, neither the ACS Gerties AD nor the Bendix AD, address this whole issue of switch to key integrity that might allow the key to be removed when it's not in the off position, which is where the danger occurs. Not only don't either of the ADs address this problem, but there's nothing about this in the Cessna annual inspection checklist. There's nothing about this in any Cessna service bulletin. There's not anything about this in Part 43 Appendix D, which is what tells mechanics what they have to do during an annual inspection. Somehow or other, this whole key integrity issue seems to have fallen through the cracks, even though the NTSB is aware of 4 fairly serious accidents or incidents involving this problem of the switch not being in the off position when the key is removed, and who knows how many incidents that the NTSB didn't get involved in because luckily nothing really awful happened. Interesting about obviously the NTSB, when they were investigating Larry Kramer's accident, they talked to the IA who had performed the annual inspection on the airplane about 6 months and 30 hours time in service prior to the fatal accident. They interviewed the IA, and the IA the IA testified that he in fact had performed a switch to key integrity check to verify that he could not remove the key in anything other than the off position, even though there's no requirement to do that. But he said it was just his standard practice that he always does that. Good for him. And he'd verified, in fact, that the key could not be removed in any position other than off. So this kind of is a little bit puzzling. And does it make any sense that the key or the cylinder or both could have suffered enough additional wear in just 30 hours to defeat the switch's key retention function? And that most likely not. What is more likely is simply that the key that the IA used to do his test was not the same key that was in Larry's pocket. In my experience, most owners provide their mechanics with a spare key when they drop their airplane off for annual, rather than handing them the key off of their primary key ring. And many owners leave a key at their shop on a permanent basis that's not used for anything but by the mechanics. You go to most shops and there'll be a board someplace with a whole bunch of hooks and aircraft keys hanging from them, and these are just keys that the owners have left down at the shop to be used by the mechanics. So those keys are probably in pretty pristine condition because they're only used like once a year, whereas the key that the pilot actually carries around with him is used a whole lot more often than that. By the way, speaking of pilots and key rings, this is a really good way to wear out the key in the lock cylinder. Is to hang a bunch of keys off of the ignition key. You put that weight on the key and then the vibration of flight, and it's just a perfect prescription for wearing out the key in the lock cylinder. And most likely that's how the retention mechanism eventually gets defeated through excess wear. So if you're in the habit of doing that, you might want to think twice about it. It really shouldn't be hanging a bunch of stuff off of the key that you use in the magneto ignition switch. So let's talk a little bit about survival strategies. The first survival strategy, probably most important, is to always assume that magnetos are hot, regardless of the position of the ignition switch or the location of the ignition key. I mean, I know when I was learning to fly that we were always taught that you should put the ignition key up on the glare shield where you can see it while you're doing your pre-flight. We were never taught that there was any hazard, any possibility that there might be a hot magneto when the switch was not in the lock, but clearly that's a possibility. That, of course, there are other ways that magnetos can be hot, and you can have a fractured P lead and so on. So it's important to do a functional check, but always assume the mags are hot. Corollary: don't rotate the prop by hand unless you absolutely have to. There's a significant risk involved in doing that. I see a lot of pilots that are in the habit of when they park their airplane, they will rotate the prop to some position that they find pleasing. A two-bladed prop, frequently they want to have being horizontal, a three-bladed prop. Sometimes people want a blade down in case it rains. They want water to be able to drain out of the spinner, out of the blade that's pointed down. But it's really not a great idea to do that. And if you absolutely feel compelled to do that, try doing that by blipping the starter motor while you're still inside the airplane, out of harm's way, rather than manipulating the prop by hand. If you absolutely must rotate the prop by hand, then always rotate it in the direction opposite of normal rotation. If you have magnetos with impulse couplings, the mag won't fire if it's being rotated in the reverse direction of rotation, but if it's being rotated the normal direction of rotation, then there's a chance that if the mag is hot, it will fire and try to start the engine. I know a lot of pilots don't like to turn the prop in the reverse direction of rotation because somebody taught them that doing that can be harmful to dry vacuum pumps. I've been doing it for 5 decades, and I've got a pair of $1,000 400 series vacuum pumps in my airplane, and I can tell you, at least from my experience, that this business is an old wives' tale. I've never damaged a vacuum pump by turning the prop backwards. It's just, I think it's just one of those old wives' tales that refuses to die. So, and besides, I'd rather compromise a vacuum pump than compromise a human life. So it just doesn't make sense to do that. So if you have to turn it, try not to turn the prop by hand, but if you have to turn it in a reverse direction. In addition, you want to get in the habit of doing regular mag switch functional checks. The really two checks. One is a check to make sure that the key can't be pulled out other than right when the switch is in the off detent. And the other, which really applies to Bendix switches, is to make sure that the engine doesn't run when the switch is in the extreme left-hand position, which is actually a little bit to the left of the off detent. If you don't know what brand switch you have, you might as well do both of those. It doesn't hurt, but for sure, the key retention mechanism integrity check, to make sure that the key can't be removed except when the switch is all the way in the off detent, is really important. So I guess this is what we're just talking about, the two checks that you do. One is to make sure the key won't come out in any but the off position. The other one is to turn the switch all the way to the left and make sure that the engine quits. Don't rely on the checks that your IA does during annual inspections. The switch to key integrity check is probably not on his checklist. There may be some IAs that are in the habit of doing it, but most probably aren't, because it's not required by any AD or service bulletin or any checklist I've ever seen. Probably should be, but it isn't. And then even if the AD does perform the integrity check, he's probably using a different key than you're using, and in which case the check, it really isn't valid, because maybe his key won't come out in any but the off position, but your key, which is a little bit more worn, might very well come out. So that's why it's a check the pilots really ought to be making. Now, I've been talking about pilots, but mechanics really need to observe these self-protection strategies as well, because mechanics probably turn the propeller by hand more than pilots do, and are definitely at risk. So, before manipulating the propeller to do a compression test or a bore scope inspection or a cylinder change or any of the zillion things that cause mechanics to need to rotate the crankshaft, be absolutely positively sure that both mags are grounded out. Use a buzz box or an ohm meter, or short them to ground with clip leads. Just be absolutely sure that the mags are not hot, because an uncommanded engine start inside a crowded maintenance hangar would not be any fun at all. And Tim, that's all the prepared material that I have for tonight, but I would be happy to take some questions if there are any.
Okay, Mike, excellent. We do have some questions that have been streaming in so far. Let's try and pull some out of there. So Thomas wonders, if a magneto is hot and we slowly turn the prop, holding it so that we hold the prop to prevent it from turning fast, can the engine start?
Absolutely. There are two starting systems that are used with magneto ignition systems. One is called a Bendix shower of sparks system. That's actually the safer system, because the engine won't, the magnetos won't fire in a shower of sparks system unless the master switch is on. It requires battery power. But the majority of magneto-ignition aircraft use a different system, which is called the impulse coupling system. And if your airplane has impulse couplings, then when you shut down the engine as it's coming to a stop, you'll hear a click, 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 and that's the clicks coming from the impulse couplings. And impulse coupling is the problem is when you crank an engine with a starter motor, you're only cranking at about 50 RPM, and that's not enough to generate a spark with a magneto. The magneto has to be turning a lot faster than that. So the way the impulse coupling works is as you turn the prop, no matter how slow you turn it, you're winding up a spring in this impulse coupling device, which mounts between the engine drive and the magneto. And after the spring is fully wound up, a pawl trips and lets the spring turn the mag over quite rapidly and generates a nice hot spark for starting. So no matter how slowly you creep up on that pawl, once it's tripped, the mag is going to turn rapidly, no matter how slowly you turn the prop. Now, the impulse coupling doesn't work if you turn it backwards, which is why turning it backwards is always a lot safer. But if you're turning it forward, doesn't matter how slow you turn it, it's still going to generate a spark if the mag is not grounded out.
Daniel wonders if you could please explain why the R position of the switch is on the left and the L position of the switch is on the right.
I have absolutely no idea. That's a great question. It probably dates back to Charles Lindbergh or something. I have no idea. I love that question.
Lawrence asks, is the 2000 hour based on aircraft hours or engine hours?
They never say about that. It's time in service, and time can be measured in lots of different ways. It can be measured by takt time. It can be measured by a Hobbs meter, and you're free to choose whatever method of measuring time in service you want to. I always say if you have multiple ways of measuring it, use the one that runs slowest. Then you do maintenance less frequently. But there's the FAA is not specific about exactly how you're supposed to measure the time.
Paul wonders, can it make sense in the case of the 2000 hour requirement just to replace the switch with new when the switch reaches its 2000 hours?
Well, when you do that, when you comply with the, let me phrase this a different way. When you install the $25 kit, effectively you're replacing everything in the switch that could possibly wear with new stuff, except for the lock cylinder. That's the only part that's not addressed by the kit or by the AD. So, I think, I'm trying to remember, I think those switches to put a new one in, I think they're on the order of maybe $300. So it would probably not be unreasonable to put a brand new switch in there, and that way you're putting in a new lock cylinder. That, of course, the problem is now your key won't work. You'll have a different key, which is probably why most people don't replace the switches with new. Of course, in the case of the Bendix switch, if it flunks the engine doesn't stop when you turn it all the way to the left test, you pretty much your only option is to replace the switch.
William says, won't doing frequent checks to make sure the key doesn't come out increase the wear on the switch, seeing if you can get to do something it's not supposed to do?
Well, I mean, not unless you're trying to pull it out with a crowbar or something like that. I actually think probably the most important thing to do to minimize the wear is to not put a lot of weight on the key, and optimally you would just have the key all alone, or with some something some light leather strap or something hanging from it that doesn't put a lot of weight on it and cause a lot of vibration.
Several people have chimed in and said they do the mag switch check before they shut down, before they do their mixture idle cutoff. They check the ignition switch. What's your thoughts on that?
It makes perfect sense to me. Like I said, it doesn't matter when you do it. You can do it during the pre-flight, or you can do it during the pre-shutdown. What do you call that? Pre-shutdown.
Shutdown, yeah.
That's perfectly reasonable thing to do.
Dave wonders, is it important for avionics health to turn off the avionics master when rotating the key to the off position during idle?
Um, it depends on the generation of avionics. Older avionics sometimes are sensitive to transients on the bus. Newer avionics typically are pretty insensitive. They'll operate on anything from 10 to 30 volts, and the first thing that happens when the voltage goes into the box is that it gets regulated down to 5 volts. So the modern avionics are usually pretty insensitive to that, but when in doubt, it's always a good idea to shut the avionics master switch off before you start and stop the engine.
Gary wonders, can you replace the switch with two separate toggle switches?
Well, it depends. If it's an experimental aircraft, you can certainly do that.
Mm-hmm.
If it's a certificated aircraft, that would be probably, most people would consider to be major alteration, and you'd probably need to get a field approval to do that. I fly a twin, and twins don't have this sort of switching, and they use toggle switches. So it's sort of a non-issue in the twin, and I think toggle switches are a better solution, a whole lot more robust than these key operated switches. But the key operated switches seem ubiquitous in single engine airplane, particularly in certificated ones. What's used in experimentals is a bit of a mixed bag, but if I were building experimental, I would use toggle switches and not use one of those key operated things.
Mm-hmm. Gilead says, I've heard momentarily turning off the key switch while the engine is running can cause damage. I used to do it to test grounding before shutdown, but I've started checking right and left rather than off. What do you think?
Well, hopefully you don't have a Bendix switch, because you're required by AD to do the off check at least every 100 hours. Turning the ignition off momentarily is not going to do any damage. So I wouldn't be concerned about that.
Joan wonders, could a faulty ignition switch cause the engine to shut down in flight and shut down the glass panel in the cockpit?
It couldn't affect the glass panel in the cockpit, because the ignition switch only affects the magnetos. It doesn't affect anything else. But I mean, in theory, the faulty ignition switch could shut both mags down in flight. The likelihood of that happening is not very great. What's much more likely is that it is failure to shut the mag off when you're asking it to. because remember the mags just are naturally active, and it requires this switch to ground them out in order to disable them. So if a switch contact goes bad, or if a wire breaks, or any of those things, the result's going to be a hot mag. It'd be a very unusual circumstance to get two cold mags in the middle of a flight due to ignition switch problem.
Jan says, is there a danger of destroying the exhaust manifold from turning an engine on and off then quickly? What about light props and hand prop aircraft? That must speak to the doing damage and the thought that you can do
Yeah.
damage, maybe your
Well,
exhaust, maybe backfire perhaps, or
the concern, first of all, the prop would have nothing to do with it. The concern, if you turned the ignition off more than just momentarily, and we're talking about just turning it off just long enough to hear the engine start to die and then turning it back on. If you turned it off for longer than that, the concern would be that the prop is rotating, the engine is continuing to pump air fuel mixture into the cylinders. It's not combusting because you've turned off the ignition, so the air fuel mixture is then passing out the exhaust valve. And then when you light the engine back off, you turn the engine back on, uncombusted air fuel mixture in the exhaust could cause what's called an afterfire, which sounds like a pop. The afterfire problem almost never happens when you're doing this check. There are various times when it happens. Frequently, when you pull the throttle way back on approach, you pull it back to idle. Sometimes you hear a popping sound, but it's very unusual for an afterfire to do any damage. It mostly just scares pilots because it's a funny sound, popping sound, but it's not really a concern, and it almost would never happen if you do this mag switch functional check correctly, where you're just turning it off just momentarily and turning right back on.
Michael says, I found no RPM drop during a mag check for only one of either the right or left. Was this a sign of the mags was still hot with the switch off?
Well, that's one possibility. If you're getting no drop when you switch to a single mag, it is. There are various reasons that could happen, but one possibility is that you're actually not grounding out the other mag, and you're actually still running on two. And the best way to check that is to, again, briefly turn the switch to the off position, and if you have a hot mag, the engine won't quit. So it's easy to check that. There are other reasons that you might not get a mag drop on one mag, and typically that would be that the mag is significantly out of time and needs to be retimed. But one possibility is that there's a hot mag. It's not always because the switch is bad. It can be because the P lead has broken. That's a fairly common failure. A broken P lead. They typically break at the magneto end inside the engine compartment, and typically because there's a tremendous amount of vibration there, and eventually the P lead can fatigue fracture. which is just another really good reason to always assume mags are hot, even if the switch is off, because a broken wire is all it takes to have a hot mag.
Erwin says we have a club with 18 members. Some members' keys pull out in any position and some do not. What do you suspect?
Well,
Warren keys or Warren retention feature?
it's probably a combination, but I mean that's just kind of a proof of what the NTSB found in the case of Larry's accident, which is that the key wear makes all the difference. Larry's a perfect test case because the IA's key didn't pull out in anything but the off position, but Larry's key did pull out in any position. So what you're reporting with the club is, corresponds with that exactly. So it sounds like it's time to possibly replace the ignition switch, and almost certainly it's time to get a bunch of key blanks and give the members new keys that aren't worn, and tell them not to hang a bunch of heavy stuff from their keys when they're flying the airplane.
Richard says, I additionally check the switch while watching the buzz box while timing and wiggle the mag switch. I've found some where I found a position where the mag was hot in an off position. Better check.
Oh, with the switch turned off, but if you wiggle the key, you can get it to unground.
That's
That's
what
a
he's
little
saying. Mm-hmm.
that's a little scary. It'd be interesting to know what brand of switch that is, but yeah. Um, Again, these switches are, I mean, they've been around for a long time, but they're sort of bad news. They're not very robust, and they've got a lot of failure modes, and you need to be very wary of them.
Dave says, so old keys should just simply be retired, right?
Wouldn't be a bad idea. Yeah, that's clearly one of the big culprits in this key retention problem is worn keys.
Robert says, I've been doing this wrong forever. This is the most valuable webinar ever.
Well, it seems like a peculiar subject, but it's kind of scary when you get into it.
We all just take it for granted, right? It's just
Yeah,
so simple.
absolutely.
And it's just a key. It's just a switch, but it's so
Yeah.
important. Um, Philip says, my RV has dual electronic ignition PMAGs. Does it have the same risk as magneto installed aircraft?
That's an interesting question, and that one's kind of above my pay grade because the PMAG is experimental only, and so I'm not that familiar with it since I deal with almost exclusively certificated aircraft. But I'm pretty sure the PMAG is self-exciting. It doesn't depend on the aircraft's electrical system like the SureFly or some of the other EISs do. And so I really don't know what it takes to get that thing to throw a spark during a start sequence. But that's a very interesting question. I wish somebody who knew more about this would pipe up and answer that question, because I don't know how to answer it.
Michael says my switch has TCM A1596-H on the label. Any idea what that is? Is it a date code or part number? What is it?
It's probably a part number, and it certainly indicates that you have a Bendix style switch.
Stephen wonders, can you replace the keyed ignition switch with two separate toggle switches and a third start switch / push button or pull to start handle?
Well, probably not a pull to start handle, but that was, I think there was a similar question earlier.
Yeah.
If it's on a certificated aircraft, that would be a major alteration, so it would probably require a field approval to do that. If it's on an experimental aircraft, knock yourself out.
Mhm.
In fact, if it's an experimental aircraft, I would get rid of the key switch if you've got one.
So John says, does failure of key retention require replacement of cylinder lock?
Yeah, except that I don't believe that you can that you can buy the locking cylinder separately. I think you have to replace the whole switch. I don't believe that it's possible to replace the locking the cylinder mechanism. I suppose you could try to take the thing to a locksmith, but I would be kind of doubtful that it's repairable. I would think that you really need to replace the switch.
We're all going to be going to the hangar and checking this, seeing if we can pull the switch
Yeah,
out of the key out of the ignition.
yeah. I'm wondering how many field approval applications for toggle switches are going to come out of this webinar.
Yeah, right. Yeah. Matsuka wonders, should the shutdown procedure start with magneto switch to off rather than cut the mixture?
Well, there's kind of a good reason to shut the engine down with the mixture control rather than by turning off the ignition. And that is that that if you shut it down with the mixture control, you're pretty sure there's no residual fuel in the engine that could that could cause it to fire. We don't really want to have residual fuel in the engine. So I don't think anybody recommends shutting down the engine with the ignition the way you do an automobile. The ignition key or the key switch check involves just momentarily turning it to off to make sure that the engine starts to stumble, and then turning it back on and shutting it off the normal way with the mixture control.
David wonders, should there be documentation by the pilot when they do the 100-hour AD switch check?
Well, if they wanted to comply with the AD, there certainly has to be. You need to make a logbook entry and sign it off with your signature and your pilot certificate number, just like you would if you were doing preventive maintenance.
Every 100 hours?
Every 100 hours.
Wow, I bet that's one of those ADs that, hardly ever gets complied with, right?
Well, but if you don't, the IA is supposed to catch that when he does your annual for sure.
Hmm.
But the thing doesn't, the requirement in the AD is not every annual, it's every 100 hours.
Mm-hmm.
So if you're flying more than 100 hours a year, doing it once a year theoretically is not enough. But I bet you it's one of those things that's almost never complied with properly. I agree with you.
Well, I mean, a lot of pilots have a real reluctance to want to write anything in a aircraft logbook, right? And they're thinking they can't. That's for AMPs to write in. So
yeah, no, that's wrong.
yeah. Richard was wondering, is the ACS switch certified replacement for any airplane?
That's a good question. I'm pretty sure that we know of cases where aircraft that had a Bendix switch got an ACS switch put in instead, but I suspect that that's considered to be a minor alteration. I think the exception would be if you had a shower of sparks ignition system, the Bendix shower of sparks, then I think you probably need to have a Bendix switch because it has a whole bunch more functions. But if you've got an impulse coupling engine, which is what most have, then I think you can put in either the Bendix or the ACS switch. And I think switching back and forth would probably be considered a minor alteration.
Walt wonders, are the ignition switch checks valid if one magneto is replaced by an electronic equivalent?
Yeah. It still uses the same switch to ground out either the mag or the EIS, either one. They're both designed to connect to a P lead to go to the switch.
Warren says that we should need to point out that the off check is performed below 1,000 RPM. I think most of the questions are thinking that the check is being performed at above 1,000 RPM.
Yeah, no, it's performed at at low idle, so it's as non-violent as possible.
Stephen wonders, what's the P in the word P lead stand for?
Oh God, I used to know the answer to that.
Is that an A&P test question or something?
Yeah, I bet somebody knows the answer to that because I used to. Primary, that's what it stands for. It's grounding out the primary of the coil. Yeah, that's what the P stands for. Funny how the brain works. It takes a while to do the associative connection.
And just following up, just following up this, Riley was just wondering, so as a pilot, I have to put the mag check in my aircraft logbook every 100 hours to be legal, question mark.
If you have one of the Bendix ignition switches that is specified in the AD, not all Bendix ignition switches are subject to the AD. There's an applicability section that indicates what serial numbers and what part numbers and what markings on the switch make it subject to the AD. But if you have a Bendix switch that's subject to the AD, then you're supposed to do the all the way to the left check every 100 hours, and you need to log it to comply with the AD.
John wonders, is there any kind of
And
spray?
you don't just log it and say did the check. You have to say complied with AD 73, whatever it is, or what a 76, whatever the number was, through functional check and then sign it off.
Michael says Electro-Air has an STC ignition switch that has mag switches toggle and a push to start button available at Aircraft Spruce.
And what is that? What is the approved model list for their STC? That's the question.
You'd have to check it out. Yeah.
Yeah,
Daniel
I guess so.
says,
But that's interesting.
Yeah, Daniel says the Citabria has toggle switches for mags and a push button for the starter.
Excellent. That's a good system. That'd be. That's interesting. I'll want to check out that Electro-Air STC and see what its applicability is, because that would be a good thing to know about. I love how stuff comes up like this and during the Q&A of these webinars. That's great information.
Well, Kenneth says PMags need ship's power to start. The self-powering ability needs to be at least RPM to function.
Gotcha. Okay, good. So that means that the PMags would be relatively safe in terms of prop manipulation. Good information. Thank you.
I know on my 2-cycle Rotax 503, electronic ignition, Ducati electronic ignition, that prop would need to rotate at least 300 RPM to fire the ignition. Okay. John wonders, is there any spray you can use to help the switch/key from wearing?
I'm not sure. I would probably not want to use a liquid lubricant for fear that it would just collect dirt and dust and stuff. Um, Usually the best thing to use in locks, and I'm not sure about the ignition switch, but it is usually a powdered graphite.
Mm-hmm.
But obviously you wouldn't want that graphite to get into the switch plate area because it's conductive. So I
Ooh, that
don't
might
know
be a
enough
big
about
no-go. Yeah,
I
that
don't
might be
know
a big
enough about
no-go.
how those lock cylinders, whether there's there's any way that squirting something into the lock cylinder could make its way back to the switch plate. Probably not, but I don't know that for sure. So
Probably just not a good idea. Yeah.
it's cheaper to just replace the keys.
Yeah. Get a nice good key in there. David wonders, can you keep the switch AD log in a separate logbook?
Uh, well, I mean, the answer generically is you don't even need a logbook. The, the FAA requires that you keep maintenance records. It says nothing about the form of those maintenance records. You want to keep your maintenance records in a computer file, or on 3x5 cards, or on post-it notes on your bathroom wall. It's all legal. The only thing the FAA talks about is what has to be in the maintenance records, not what form they take. I mean, if they were all on post-it notes in your bathroom wall, it might get a little inconvenient when you go to sell the airplane, and you might have to invite your IA into your bathroom during the annual to do the research. But so it's probably not a practical way to do it, but it's perfectly legal. But yeah, you can keep as many or few logbooks as you want to. You could have a special logbook just for ignition switch checks. Probably your IA would want to see that to make sure you've been doing them, so he doesn't have to do them.
John says engines with electronic control modules, ECM, need battery power to turn on ignition instead of grounding to turn it off. So an open wire means no ignition instead of always on. Okay, Gomer wonders, other than the key cylinder feature, is it permissible to repair a Gerties switch with the ACS kit?
Yeah, they're identical. The ACS and Gerties switches are exactly the same. It's the only difference is what it says on the sticker.
Mike says some of the old Bendix ignition switches didn't have a key. They had a lever attached. Are those subject also?
Um, I don't think so, but I'm not 100% sure. As I said, the AD has a specific applicability list in there, of certain part numbers. But my general sense is it probably only applies to the ones that have keys.
Eric says, I had an engine failure due to switch problems in a 1969 PA-28.
How did that happen?
Maybe he'll
Look to
chime in
find.
and tell us.
Yeah.
Paul says some people suggest pulling the prop through a few turns before a cold start to lubricate the engine. This is dangerous, but does it actually protect the engine?
No, It really doesn't help. It's it's a very common habit that people have, and as far as I can tell, it has absolutely no beneficial value.
Yasin says, can a switch fail to ground at the off position but still pass a run up left and right mag check?
Certainly, certainly.
A lot of comments in here. I'm sifting through the comments to get to actual questions.
Are
And
they good comments or bad comments?
well, just exacerbating kind of what we've been talking about. Where do you go to get copies made of an unused original ignition key? Mark wonders.
Well,
Hardware store,
I I know
Lowe's.
I've gotten copies of Cessna keys made at at the the key kiosk at Home Depot or something like that.
Mhm.
I can't vouch for every make and model, but the keys tend to be pretty simple minded, and I think the blanks are pretty readily available.
David tells us I had a bad switch, not grounded at and not grounded at off, and it kicked back, and it says it only broke his hand though.
Oh,
So
that was probably one of the ones that the NTSB doesn't know about. Oh, maybe they do now. Maybe somebody from the NTSB is listening in, but yeah, unless there's blood on the tarmac, the NTSB probably didn't get involved. So,
Mike just wanted to say thank you for a good presentation, and I've gotten copies of keys at Lowe's. Bruce and a couple other people say. Okay, Neil says, question, when shutting off the engine by pulling the mixture out, does this mean no more fuel in the engine? And why then a hot mag can start the engine?
well, that's a good question. The explanation has to be that when the mixture control was pulled to idle cutoff, it reduced the fuel flow into the engine to the point where it could no longer sustain combustion, but it didn't cut it off absolutely completely, and there was some residual fuel. In Larry's case, they flew in, did some errands, and he was doing the pre-flight a couple hours later, so there apparently was a little bit of residual fuel in there. And chances are that if he hadn't done the pre-flight for 24 more hours, maybe there wouldn't have been any fuel in there. It was a particularly unfortunate series of events.
Ken says, I have an ACS switch in my experimental, and it is a struggle to remove the key. I've chosen to leave the key permanently in the switch. Do you see this as an issue?
Well, I mean, it's kind of one more step in the safety chain that part of the safety should be that if you have the key in your hot little hand, then you're supposed to know that the switch is off and the mags are grounded out. Obviously, that doesn't always work, but if if you can't remove the key, then you don't have that assurance, and you'd have to be really super careful that the switch was in the off detent. And as you could see from the picture that I showed with Larry's airplane, the difference between being in the off detent and being just a little bit out of the off detent and having a hot right mag wasn't very obvious. You'd have to really stare at it to see the difference. It's pretty subtle.
Gene had to suggest.
I was
Go
going to
ahead.
say, put in some toggle switches and just eliminate the whole issue.
Electro Air STC.
Well, he was, I think wasn't it experimental? Didn't he say
Oh
it
yeah,
was
yeah. That's right. That was experimental.
yeah,
You can just do it anyways. I
yeah.
was thinking of all the T-Seed folks. Gene had a suggestion for the keyware issue and the flying club that has a lot of keys out there. Find a new or the very best key and never issue that again. Use that key only to make copies that you issue to other people with.
Mm.
Let's see here. Larry says Cicada Trinidad ignition switches go off, left, right, both, which makes a lot more sense.
And their props rotate in the opposite direction. Is that?
Leave it to the French. Yeah. Let's see here. Let's see. Caleb wonders, are there any keyed ignition switches that are not subject to either of these ADs?
Yeah, there are some Bendix ones that are not subject to any recurring AD.
John was wondering, could you put that AD number up again?
But again, neither of those two ADs address the issue of key retention. That's really important. Can I put up the number of the ADs? Is that the
Yeah,
question?
yeah, please, John was wondering.
Talk amongst yourselves, and let me see what I can come up with here. Okay. There's the Bendix one. It's AD 760712. Write that down real quick, and I'm going to find the ACS one. There's the ACS one, AD 930506.
And a couple of people were wondering, do turbine engines have ignition switches like this?
No. As far as I know, all turbines use toggle switches.
Mm-hmm.
And they don't have like hot mag kinds of things.
All right, Mike. Well, I think we've kind of exhausted the questions here. We got a lot of great comments from everybody, but I think our questions here are pretty much dried up. Why don't you take a moment and share closing thoughts with us? Boy, we had an excellent turnout of over 1,300 people that I saw
Oh
on the
my,
counter.
that's fantastic. That's fantastic. Thank you everybody who came. If you're not already on my email list and you want to get on, no cost, no obligation. The easiest way to get on the list, at least if you're in North America, is to text the word SAVVY, SAVVY, to 33777 on your phone. Other ways to do that are to go to the savvyaviation.com website and click on the link way up at the top of the homepage that says that you want to be added to the newsletter mailing list, or to hang around. The best way is to hang around and take the post webinar survey that Tim's going to put up, and check the little box that says you want to be on the list. Any of those ways will get you on. My 4 books are available at the EAA bookstore, Aircraft Spruce, on Amazon. And the first two books are available also in audiobook form on audible.com. And we're busily working on the third book, audiobook, which hopefully will be ready in a month or two. These are kind of big audiobook projects because the books are all but the first book are 500-page monster books. I invite you to listen to the Ask the A&Ps podcast that I do with my colleagues Colleen Sterling and Paul New. We now do it twice a month, and it's a call-in show. So if you'd like to participate in the podcast, please send your questions, the thorniest problems that your A&P is having a hard time solving, to podcasts@aopa.org, and our producer Ian Twombly will schedule you for our next recording session and get you on the show. Finally, upcoming next 3 upcoming webinars. First Wednesday of the month webinars, January 3rd webinar, time and materials, talking about the fact that we pay for aircraft maintenance in a rather different fashion than we pay for automotive maintenance, questioning why it's done that way, and maybe there are some better approaches that might be explored. February webinar is called 6 Big Mistakes. It's the 6 biggest mistakes that I see aircraft owners make in managing the maintenance of their aircraft. Somebody asked me to write down the 5 biggest mistakes, and I couldn't confine it to 5, but I managed to whittle it down to 6. So that's what the February webinar is about. And finally, the March 6th webinar is we're going to be talking about unleaded avgas, and in particular, this decision not very long ago that University of North Dakota made of discontinuing their participation in the Swift UL94 trial that they've been running their fleet on Swift 94 UL for last year, and decided to stop doing that. I want to look into why that was and how much of a how much of a setback that represents in terms of our transition to unleaded avgas that the EPA is now mandated on us, and that most of us have felt would be quite a positive step of moving to unleaded avgas. But anyway, we're going to explore that in the March webinar, and that's about it, Tim. Till next year.
Yes, thank you so much, Mike. That was a fantastic presentation, very informative as always, and looking forward to next year, starting off 2024 with a good one, I think. So really looking forward to that. Thank you so much, Mike. Happy holidays to you, and to everybody who tuned in, thank you so much for joining us. Have a wonderful evening, everyone.
Yeah, happy holidays. See you next year, everybody.